Good afternoon, or good evening, or good morning. I'm not sure when you're watching this, but this is our first on-demand lesson for this year's seminar. So first of all, thank you for meeting me here. Because of the state of emergency in Tokyo, we can't meet on campus, so it's going to be best to make the content available online. And since the answers I got to my survey were more, the idea of having an on-demand lesson was more popular than a real-time WebEx lesson, I thought I'd give this a try. So we're going to continue the topic we started last week. We need to study some of the details about sound in order to understand the characteristics of speech sounds that we're going to study. So last week I introduced the terms frequency and amplitude. So I want to begin by repeating those. In fact, we'll repeat maybe the last 5 or 6 slides from last week, and then we'll continue on to some new information building on that. Okay. Now, if you have any questions, you can't just raise your hand and contact me, but you can send me an email. I will happily answer questions by email. You can post a question in the forum in Manaba. I will keep an eye on that. Somehow I'm available to answer questions. I realize this topic can be a little confusing, a little difficult to follow sometimes, especially if my voice doesn't last. You know? But so please don't hesitate to contact me if you have questions. Okay. So as you can see on the title slide, this is from last week. We started speech sounds, and we had this list of items: sound as vibration. Right. We talked in some detail about how low frequency sounds are sounds where there's some kind of vibration that is slower than high frequency sounds. High frequency sounds are produced with faster vibrations. And we hear that in the human voice, right? A low voice, right, is produced by slower vibration of the vocal folds than a high voice is produced with faster vibration. Okay? And we measure vibration using what's called hertz. It's the unit that basically counts how many vibrations occur each second. Right? So a low vibration rate, a low frequency, like 50 hertz, for example, would vibrate 50 times every second. That seems fast, but in fact for sound, it's not. Faster would be like 1,000, 3,000. Speech sounds basically depend on frequencies as high as about 4,000 or 5,000 hertz. But the human ear, human hearing, can detect frequencies somewhere in the area of 20,000 hertz. But those frequencies are not important for distinguishing speech sounds. So as we begin to study the frequencies of speech sounds, we'll see that the important range is somewhere between 200 or 300 hertz and maybe 4,000, 5,000 hertz. Okay. Now, last week I began the topic of the power spectrum, and I want to repeat that today because that's a very important graph, a very important way of representing on paper or on the screen a characteristic of sound. Okay? So I want to repeat my introduction to the power spectrum, and that's where we'll see harmonics, a natural vibration that occurs at higher frequencies in response to a fundamental frequency, a basic frequency that is a lower number of hertz, a lower frequency. And then we'll describe the base frequency of not only a simple vibration, but the complex vibrations we see in the human voice as the fundamental frequency. And the notation we use will be the F with a little 0. Right? So this F0 here, right? It refers to the fundamental frequency. And I think I explained that often students confuse fundamental frequency with formant frequencies. And it's true, it looks a little similar. They're both F with a little number next to it. And so hopefully today I'll make clear what is a formant frequency and how is it different from the fundamental frequency. And the notation, as I just said, is F with a little 1 will be the first formant frequency. F with a little 2 will be a second formant frequency. And then the third formant frequency. And in principle, there could be a fourth or fifth or sixth formant frequency, but those turn out not to be important for distinguishing speech sounds. There are other characteristics of sound we can detect with those higher frequencies, but we want to focus on the characteristics of speech sounds, so that's why we will keep our discussion to the first 3 formants. And today, in fact, we'll be beginning with the first 2 formants, because the first 2 formants can be a kind of measurement of 2 important characteristics of pronunciation in vowels. We know, for example, that some vowels are pronounced with the tongue in a high position in the mouth, like E and Oo. So the tongue is high and close to the top of the mouth. Some sounds are made with the tongue low in the mouth, like ah and ah. Well, that difference in tongue height can actually be measured in a property of the sound. In fact, in the F1, the first formant. And so we'll learn how to do that, and we'll learn what that means exactly. And then F2, the second formant, is caused by the particular position of the tongue in the mouth, whether it's pulled toward the back of the mouth or pushed toward the front of the mouth. Okay? And then we're going to be ultimately looking at a spectrogram, and that's our goal, right? A spectrogram is something that we produce on the computer, and it creates a kind of graph that shows these frequencies over time. And the important thing will be these kind of dark lines, okay? And we'll learn about those today. So you see how the dark line has a certain pattern, okay? That's our objective. Now, since this video is available on YouTube, by all means, be sure to take advantage of the YouTube tools. If you want to watch the video more slowly, you can just, I don't know, here, maybe over here, click on that little gear button and change the speed of my voice. Or if I'm speaking too slowly, you can make the speed faster. There's also a CC. You can click on the CC button for closed caption if you want to see the English written down here. And that will maybe help you catch everything that I'm saying. But it's up to you. You're welcome to watch it just as you are now as well. Okay? Okay. I'll stop this video here and then see you in the next video.